Welcome once again. This is for all Form 2s, that's basic 8 students. Good. And today we are going to look at something new, right? We know you just came to basic 2, basic 8, but don't worry, we got your back. Today we are going to look at mixtures, mixtures. Hope you are here. Good. Now, you have done so many mixtures in your life. As and now, you have mixed so many things because once you have been able to prepare something in the kitchen, once you're able to put things together, now at times yourself to do it, you buy different types of drinks and you begin mixing them together, adding things to it. That you are doing is basically what mixture is. Or what you prepared is a mixture. So with that, how do I define a mixture? I have sand. Then I have water, or I have gari with sugar. If I mix the sand with the water, except I mix, what I form is what? It's a mixture of sand and water. You get the point I'm making here? Good. And I'm doing this physically because I can see I have the water and I have what? The sand. When I mix these two together, I form what? I form a mixture. That means that mixtures or a mixture is only formed from physical combination. When we look at compounds, compounds are chemical combination of elements. Chemical combination, compounds, C, chemical combination. Mixtures are physical what? Combination. So we've all, in our lifetime, prepared what? Mixtures. So don't think much about what mixtures are. Understand this, that mixtures or a mixture is the term there is for physical combination of two or more substances without any chemical change. Because when there's a chemical change, it becomes a chemical or it becomes a compound. You get the point I'm making here? Good. So mixtures or a mixture is a physical combination. So the term we are looking at here is what? Is the physical. So a mixture is a physical combination of two or more substances. We physically combine two or more substances and we have what? A mixture without any chemical change. Once again, once you've been with us, you know, we'll upload a note to the site www.McTeeClass.com. Then you go and get a note and follow, right? Meanwhile, we print some small ones on the board for you. But the most important is for you to sit quietly and listen and understand. Be able to create the links between what we are doing. Because mixture is a very simple topic. Why? We've all done that before. So with the definition right now, you should know what we are going to do. Now, we want to look at some mixtures and their components. Now here, I hope people know what we call the soakers. Good. When I come back to my kitchen and I want to prepare any food at all, what I'm doing is mixtures. Or what I'm doing is mixtures, because I'm going to put this, add oil to this, add this to that, the moment I put those things together, I begin stirring it. You know what you've done? You've done mixtures. And most of you have done some before. You take your gari, I know some of you get your gari, you put sugar, you add water, you put milk, you add needle, you put the chilled water as well, very chilled one. And you cross your legs in your chair, you are watching your cartoons and sipping and drinking your mixture. It's just a mixture you prepare. You get the point I'm making. And each one of us have its own way of preparing this. Some people, they like their gari to be more, their sugar to be less. Some people too, they like their sugar to be more and the gari less. With more milk, I know them. That is the characteristics of mixture. For the mixture, the components vary. It's not a constant. It's not constant. Now for anytime you're preparing gari and sugar, you should have this amount, that, no. But for compounds, the ratio of the components are static or are constant. You are preparing in water, it's H2O. That is all. You can't change this. Up you are preparing HCl, it's HCl. The ratio must be the same. You have calculations before you can do these things. But for gari, that's why these ones are physical. We all can do it in our house. But you can't go and prepare water. They are done in the lab by trained scientists. Hope you understand what I'm saying here. Good. So look at some mixtures and their components. So mixtures are made up of what? Of components. Good. So we take a mixture and a component, like soil. Soil is a mixture. Components of soil, we have what? Water. We call it the soil water. We have air. We have soil particles. We have humus, and we have living organisms. These form up what? The soil. We say we have the water, the soil air, the soil particles, which is the sand or the clay part you see, then the humus, dead organisms, the living organisms, right? Good. Then we have soup. I know most of you have stolen fishes from soup, but don't worry, we are not here to tell your parents. We'll just look at it, the things in it. Now, in preparing soup, you need what? Water, salt, fish, tomato, onion, pepper, so many things we need in order to prepare what? Soup. I know most of you, the boys, too, can prepare soup. Never I'm fine. I know you can prepare that. Good. So that is what? Those are the components of soup. Then we take blood. Our blood is also a mixture. Now, the blood contains what? Water. It contains the white blood cells, the red blood cells. It contains the platelets. There is glucose. There are hormones. There are proteins. There are waste substances in the blood. A mixture of all those things. Then we take crude oil. Crude oil is also another example of what? Mixture. We have petrol. We have gasoline. We have kerosene. We have bitumen. We have LPG gas. We have lubrication oil. We also have what? Gas oil. All these things. So if you hear Ghana has discovered oil and we are refining the oil, that means we are bringing out each of these components I have mentioned. We call that separation of what? Mixtures. And that will also treat that one, how to separate them. And once we combine them physically, then we can only separate them using physical what? Means. It's a characteristic of what? Of mixture. So look at them soon. Right? Good. Then we have palm wine. Palm wine contains water, alcohol, yeast. The yeast in the palm wine is what causes fermentation after some days. It ferments and becomes very, very well alcoholic. Good. Then we have sugar, proteins, and vitamins. Yes, it contains what? Vitamins. Then we have brass. Brass is an alloy. And an alloy is a mixture of two or more metals or a non-metal and a metal. Therefore, alloys are also what? Mixtures. So take note of that. Alloys are what? Mixtures. Then the components of brass is copper and zinc. Then we have steel. Steel is made up of what? Of iron and what? And carbon. These, there are a lot of mixture, but the few we have here and their components, right? Now let's go straight away into the features of compounds. And I think I've mentioned two, if you are listening. Features or characteristics of compounds. Features of mixtures. Not compounds. We are doing mixtures. Features of what? Of mixtures. One. It consists of the physical what? Combination, or the components are physically combined. So the first one is that the components of mixture are physically what? Combined. And the second one is that the components of the mixtures are mixed in any ratio or proportion. I explained that earlier. In any ratio. Now this one is big. I thought that the topic mixtures is simple because we have done mixtures. So you don't need to go and sit and be thinking. No. A mixture basically close your eyes, get your gari in your head and your sugar, physical combination, and you define your mixtures, right? Characteristics or features of a mixture. What did I do? I took gari and this, so it's a physical combination. If I want to separate them, I'll separate them what? Physically. You get the point? If you mix water with salt or water with sugar, we can still separate them physically. When we look at physical separations, I know most of you think it's not possible, but it's possible to do what? To separate it. And I'll show you what to do. When you do it in your house, you get them. You get the sugar from what? From the water. Okay, so let's go. Now, the components also retain their properties. When you mix them, because the physical combination, nothing has changed. The definition says that without any chemical change, when there's no chemical change, that means that I am still maintaining my physical properties. You get the point? Once there's chemical change, you have changed your physical property. Like I take a paper and I burn the paper or wood into ashes. What I have done is a chemical change. I have changed the composition. It's no longer paper. You get the point? When you boil egg, it's a chemical change. But when you grind pepper, it's a physical change. You have changed the state, but you have not changed the chemical composition. You get the point I'm making here. So with that understanding, because we are not changing them chemically, they are able to maintain their physical properties. The next one said the compounds can be separated by what? By physical means. I hope you get the point I'm making here. And the composition of mixture, that's what? Vary. The composition can vary. Somebody, like I said earlier, will prefer more sugar. I know most of you go for more sugar and less what? Less gari. You get the point. But when there's milk, oh la la, plenty of the what? The milk. you add to your circuits. I hope you get the point. So we've mentioned 5 features of mixtures. 5 features of what? Of mixtures. Good. Now we'll look at the forms of mixtures. Forms of mixtures. When I say forms of mixtures, mixtures comes in so many forms or looks. Put it that way. You get the point? And the forms of mixtures depend on the state of the compounds. I said depends on the what? On the states of the components. The components involved in the mixture. When I say states, I'm looking at it as in matter, states of matter, which is solid, liquid, and what? And gas. So these, the state of the component, whether solid mixed with solid, liquid mixed with solid, or that combination, these are the forms of mixture. So forms of mixture is so easy. How? When solid mixed with solid, it becomes a solid mixture. So when we have what? A solid mixture. What? You don't also need to go and sit and from here you should understand. Solid mixture is a mixture that contains 2 or more solid components. The components that were mixed together are solids. Therefore, we call it a solid what? Mixture. What if I have a solid liquid mixture? That means this mixture contains a solid and a what? And a liquid component. You get the point I'm making here? Good. So that will be the forms of mixture. We have solid mixture, we have solid liquid mixture, we have solid gas mixture, we have liquid mixture, liquid gas mixture, then we have what? We have gas what? Mixture. And we are going to look at what each one of these is and examples of those kind of what? Of forms of mixtures. So we start with the solid mixture. I told you the definitions are all easy. What's a solid mixture? It's a mixture that consists of 2 solid substances or 2 or more solid what? Substances. Example, we have what? Gari and granite, gari and sugar. These are what? Are solids. So mixing those 2 together, we have a solid what? Mixture. Sand and stone for concrete will give me what? Solid mixture. Rice and sugar also give me solid what? Mixture. Then I have solid liquid mixture. It's a mixture that consists of what? Of a solid and what? And a liquid component. You don't think this is very easy. Solid and what? Liquid component. Mostly dissolves in what? The solid will mostly dissolve in the liquid. In this time, the solids mostly dissolve in the what? Liquid. So you can give me an example. How mention one? Mention one example. Yes, salt and what? And water. Sugar and water. These guys, when you mix them together, the salt will dissolve in the water and the sugar also will dissolve in water. So it's a solid liquid what? Mixture. Then potassium permanganate, the blue we use in washing, right? It's solid, but when you put in the liquid, it dissolves and give you that. The phenomenon for dissolution is called diffusion, which we'll tackle here in the Form 2 class. Look at diffusion and also the transport system, Milo and water. So when you go home or when you're in the house, just take Milo and water, put them together and stir. Your parents ask you to tell them you are practicing solid liquid mixture. When they are doing that, you can tell them that this is a solid liquid mixture and explain to them that is how we do our learning. Good. Then we have solid gas mixture, and that one will be made up of a solid substance and a gaseous substance. Example is dust or what? Smoke. Dust and smoke are examples of what? Solid gas mixture. Then we have liquid mixture, and that's what most of you do on a vacation day. On your vacation day, you prepare a lot of liquid mixtures. You get the point I'm making here. Somebody brings his Don Simon, another person brings his Bell Cola, and you mix things together. You don't even know the color of what you have. It's a mixture. But because it's all liquid components, we call it what? Liquid what? Mixture. Like we have Milo with what? Water and milk, not Milo. Water and milk will give me what? Will give me a liquid mixture. I take kerosene and I mix it with water. It gives me a liquid what? Mixture. Then I have a liquid gas mixture. An example is what? It's your carbonated drinks. When I say carbonated or fizzy drinks, then I mean your Coca-Cola and things. When you buy them, you say there's this gas in it. Some people, the gas is too much. You get the point I'm making. So that combination where we are able to mix the liquid and the gas is referred to as what? Liquid gas mixture. Good. Spray is also one of them. That's why we have liquefied petroleum gas, LPG. It's also a liquid gas or mixture. Good. Then we have gas mixture. It's a mixture that consists of two or more different what? Gases. Example is the air we breathe in. The air we breathe in is a mixture. Air is a mixture of gases. So it's a gas what? Mixture. Natural gas also, methane and some inorganic what? Gases. They are all these things are what? Gas what? Mixtures. Then if we take, so we look at the forms of what? Of mixtures, or we say it depends on the what? On the state. Good. So if we take the liquid mixture, if we take liquid, we can divide this into two. Liquid what? Mixture. We said this one. Let's go back to the examples of liquid mixture. We said we can have water and milk, and we can have kerosene and what? And water. These are two different types of what? Of liquid mixture. You can put it in the house. Once you add kerosene to water or oil to water, they won't mix completely. You will see that the kerosene or the oil will always settle on top of what? Of the water, because it's less dense than water. Then, if you mix water and milk, it mixes completely. Those two things, or those two examples, will tell us that we have two types of what? Of liquid what? Mixture. We have the homogeneous mixtures, and we also have what? The heterogeneous what? Mixtures. So I read here directly, classification of liquid mixture. These mixtures are classified on their ability, or the ability of their constituent element, their components, to mix uniformly or not. So we are grouping these or putting them into group based on their ability to mix completely, or not. And based on that, we have two. We have the homogeneous, and homo means same. That means uniform. There's a uniform what? Mixture. So homo means we have uniform. We have what? A uniform what? Mixture. So homogeneous mixture is a uniform mixture of two or more what? Or more elements. I hope you get the point I'm making here. So liquid mixture can be separated to homogeneous and what? And heterogeneous. So let's read homogeneous mixture. Homogeneous mixture is a type of mixture in which the constituent element mixes completely without any separation. I like this. Without any what? Separation. That means that you won't see a separation there. Everything is one, complete. Like you add water and milk together. When you add this thing together, it will mix completely. Or water and Fanta, or water and Coke, it mix completely. But the moment you add water, so let me draw a container here for you. You add water and oil, they will meet. There will always be a separation. The oil will be on top, then your water will be here. There will be a separation. That means they have not mixed what? Uniformly. They have not mixed what? Uniformly. Good. So example is water and alcohol. For homogeneous, water and alcohol, you will not tell the difference. You can't know. Or you can't tell the difference that this is no. It's uniformly mixed. The next one is what? The heterogeneous what? Mixture. We have two. We have the heterogeneous mixtures. And for them, we say what? This is a type of mixture in which the constant elements will not mix completely with what? A separate. So they don't mix completely, hence there's a separation. Take water now and pour oil into it. You see that when it settles for some time, the oil will be on top of the water. You can see the separation, the point where they met or they meet. You can see that. And that gives you an example of the heterogeneous. So you can give me an example of what? Of the heterogeneous mixture. The heterogeneous mixture or heterogeneous mixture. This we have what? Water and oil, or water and kerosene. Water and most of the organic compounds do not mix together. Are you getting what I'm saying here? Good. So now that is our mixtures. Now we've combined them. We've looked at their features. Can we separate mixtures? I add water and oil. Can I separate them? Can I put the two together? Remember, one of their features said what? That they can be separated what? Physically. So since they can be separated physically, then we can have separation of what? Mixtures. We can separate mixtures. Good. We just look at some of the ways of separating mixtures. In our next class, we take them and break them down. How we do this, the methods of what? Of separation. So the next thing we are looking at is what? Separation of what? Of mixtures. Separation of mixtures. Our next thing here is separation of mixtures. Separation of mixtures. Separation of mixtures. Components of mixtures can be separated from each other based on yes. We can separate them based on their physical properties. Very, very important. Based on their physical properties. Take note of this. Without you knowing the physical properties, you cannot separate them. We have separating methods. Yes, we have the methods of separating, but we have the physical properties based on which we do our separation. You get the point I'm making? Yeah. If you don't know the physical property of the components involved, you cannot separate them. You should know their physical property based on the fact that this one is bigger than that. Then let me use CV. You get the point? When I look at the sizes, their physical property. One is what? One is more or has a higher boiling point than the other, and I can use a particular method. One is more in lightweight than the other. I can use winnowing, where you see the moment you blow air on your granite to be able to separate the chaff from the original granite. What you are doing is separation, but because of the fact that the chaffs are of lightweight, that is why you blow air. That's winnowing, and that is why you chose that. You will not use sieve to do that. I hope you get the point. So the method of separation is basically dependent on the physical properties of the constituent elements. Good. The method used to separate mixtures which are based on their physical properties is known as the physical method. So we have physical method and we have physical property. For physical method, those are the methods we use. But before you choose a physical method, you have to know the physical properties of those guys involved. I hope you get the point I'm making here. Very simple, very well. Very simple and easy. So let's look at some physical properties for separation of mixtures. I said we can have physical properties and we have physical methods. These are the procedures. But before you can use a method, you need to know the properties. I said example is what? Is the boiling point. Boiling point. And because alcohol and water have different boiling points, we can separate them. We can separate alcohol and water that have mixed together homogeneously using what? Using distillation. And distillation works on the fact that their boiling points are widely different. Then we also have the melting point. So I said we have boiling point, we have melting point, then solubility. How soluble one is in the other, we can use that. You get the point I'm making here. Then we also use the temperature differences. So let's go. I said we have what? We have boiling point, we have melting point, we have solubility, we have temperature difference, then we have particle size. I mentioned that. Particle size. Then we also have density. It's another way of doing it. We have weight. In the case of your separating your chaff from the granite, use the weight. Through blowing the air, the lighter ones will blow off and the heavy ones will stay. Then we have magnetic properties. You get the point I'm making here. We use magnets to separate to separate this. I hope you get the point I'm making. Let's go through once again. So we have the physical properties. We say we have boiling point, we have melting point, we have solubility, we have temperature difference, we have particle sizes, we have density, we have weight, then we have what? Magnetic properties. I hope you get the point I'm making here. Good. Now let's come to now the physical properties. Some of the physical properties of what? Now that we know the physical properties, let's come to the physical methods. How do I separate them? One, we can use what we call the simple distillation. We can use what? Simple distillation. We can also use fractional distillation. So simple distillation, fractional distillation, filtration. Most of us know filtration. To use the filter paper to separate. And that one is basically, or is based on the physical property where one is soluble and the other is insoluble. So I can separate sand from water using filtration. And why? Because I'm looking at a property called solubility. The sand could not dissolve in the water. Hence, I will separate it using filtration. You get the point? I'll not use distillation. I can't use distillation to separate them. I hope you get the point I'm making here. Good. Then we have evaporation. We have sublimation. We have magnetization. We have crystallization. We have decantation. chromatography, separating funnel, sieving, precipitation, and sedimentation. I hope you get the point I'm making. Let me go over again. I said we have simple distillation, we have fractional distillation, we have filtration, we have evaporation, we have sublimation, we have magnetization, we also have what? Crystallization, decantation, chromatography, we have separating funnel, which is based on the density. You can separate oil and water using what we call a separating funnel. Then we can also use sieving based on the particle size. You can use precipitation and what? And sedimentation. People, this is just the first section of mixtures. It's a very broad topic, but very nice. The next time we'll look at simple distillation. We'll go over and see a lot of things on a simple distillation. What factories are using to produce drinks, the method they use, the simple distillation is used in so many what? So many areas. So it's applied in so many areas. We'll look at all this. So stay tuned and be very, very well serious. You get a point I'm making, very serious, so that you can get good grades in school. Thank you very much for joining the class. Once again, this is McTeeClass. You are welcome.